So today our topic is on GCD. GCD. We start from greatest common divisor. Greatest common divisor. In our secondary school, we have done greatest common divisor, but today we are going to check it in a large number. GCF also stands for HCF, highest common factor in your secondary school, or greatest common factor. So, its greatest GCD is the largest positive integer that can divide two numbers. It's the largest positive integer that can divide two numbers without a remainder. So your secondary school you do HCF. So today we are using Euclidean algorithm to solve GCD. Euclidean algorithm. Euclidean algorithm. Let us find the GCD of a simple number. GCD of 48 and 18 using Euclidean algorithm. Because if we do the GCD of large number, let's say I do the HCF of large number, it will be very difficult for you to know, for you to solve it. Very difficult and will not be correct. It might not be correct and very difficult, because you know that 2 times that one is very hard. It's very easy, but for large number it's very hard. So to find the Euclidean algorithm of 48 and 18, you say how many times can 18 divide 48? So 48 is equals to this one. How many times can 18 divide 48? Which is 2 times. 2 times 18 is 36. Is 2 times 18 plus the remainder. What is the remainder of this 48? When this 18 divides 48, you give you 2 times 8, which is 36. You now say 48 minus 36, which is equals to 12. So now put the remainder 12 here. This is you first time. This is the whole number. How many number do you get? This is the whole number. This is the whole number. This is the number you divide. This is the number that divides it. This is the ultimate number. The number that is 40. This is the 48. This is the 18. And how many 18 can I say 48? Is 2. The remainder is 12. So now say, okay, this 18, you now take this 18. This 18, say 18 is equals to this 12, this remainder. You now say, how many 18? This 18, you forget about this 12, this 2. You now say, how many 18 can you say in 12? Which is 1 times 12, this 12. You will take the remainder, this remainder. This is the quotient, you take the remainder plus how many 8? Let me not say, okay, for how many 18, how many 12 can you say? How many, if they say 18 minus 12, this 18, now 12 times 1 is 12. This 18, when you bring it home here, with 18 minus 12, which is 6. So you now say, what's the next thing? And you would have get it from now. That you take this 12, you now say this 12 is equals to this 6. This is the 6 again. 6. This is the 6. So now say, how many 12? If you do 12 divided by 6 is equals to 2. It's now what? 2 times 6 plus what? If they say 2 times 6, 12. 12 minus 12. Even you can't come here. The 12 minus 12 is equal to 0. So the GCD is the known zero remainder. The last known zero remainder. This is zero remainder. The last one. This is the last. This means this is the GCD GCD is equals to of 48 and 18 is equals to 6. That means you will take the last known zero, that means one that now have zero, the last number that now have, the last remainder that now have zero, you will take it as the GCD. So you can do some example. So the GCD of 48 and 18 is 6. And if you do it in HCF, you still get 6. Let us find in HCF, you still get 6. That is the Euclidean algorithm. So let me do an example. An example. So GCD of 3 numbers. You will get the GCD of 3 numbers. And you say, can you get the GCD of 3 numbers? Yes, you can get GCD of 3 numbers. Let us give you the formula. It's still the same way. GCD of 3 numbers. GCD of A, B, C is equal to GCD, GCD of what? A, B, bracket C. So when you get the GCD of A, B, the GC you get, you now use it for the GCD of C. So let's say you have something like GCD of 32, 42, 48. So you try this one by yourself. So you first get the GCD of 32 and 42. The GCD you get, if the GCD you get will not be GCD of 40, that GCD and 48. So let me do a complex example. So you say GCD are simple, let us do a complex example. So let us find greatest common divisor. So let us find GCD of 98 quadrillion 765 98 quadrillion 765 trillion 432 billion 100 and I'm coming. $98 quadrillion 765. Okay, I'm copying the mistake. Find the GCD of 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. Comma 9, 8, 7, 6, 5, 4, 3, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's find the GCD of this number. You know, HCF. If it's HCF, you can't find it. It's very hard to find. Even though you get it, it's very hard to find this. But if you do using GCD, it's a simpler way. So GCD of 12 quadrillion 345 trillion 678 billion 987 million 654,321 and 98 quadrillion 765 trillion 432 trillion billion 123,456,789. So how can you find this GCD of the number? So it's just simple. It's the same way. So it's the same way. So GCD of the number is the same way. GCD of the number is the same way. So you will see, even though you use AI to solve it, AI will not give you the full answer, and it might not be correct. Even though it's correct, it will not give you the full answer. It might not give you the full answer, or it may not be correct. So or if it's not correct, I don't know. We can try AI without to make it simpler. But let's follow. It's the same way. It's very simple. We say 9 98 quadrillion is equals to how many 98 trillion, how many 98 trillion and 98 quadrillion 765 trillion 321 billion 234 million 598 quadrillion 765 trillion 432 billion 123,456,789. Can you find the second one, which is 12 quadrillion 345 trillion 678 million 876 million 430. How can you find this? That will be 8 times 1 So it's 8 times something. 8 times 6, reduce something. So you now minus 6, you get the answer. When you get this one, when you times 6, when you times this one, you now minus it with this one. So we'll give us the remainder of what? We'll give us the remainder of 222,000, 222 million, 222,000, and 221. So when you now get this one from our previous one, you will get the quotient. This is the whole number. So this one divided by this one is equal to what? Twelve, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1.